Already in the last session we have learned about the basic characteristics of object orientation. Okay, just can you please tell me? First one is class, second one is object, third one is encapsulation, and fourth one is data abstraction, fifth one is inheritance, and sixth one is polymorphism, seventh one is dynamic binding, not yet discussed about, and last one will be message passing. So these are the basic characteristics of object orientation. Now let's have a look on all these things briefly. Okay, first, what do you mean by class? So class is user defined data type. Class is user defined data type declared using the keyword code as class, and after that we will be giving what the class name, which is going to bundle, which is going to wrap up or encapsulate data members and associated member functions. Okay, so what do you mean by class? Class is user defined data type constructed by making use of basic data types, where we are going to bundle data members and associated member functions. The next questions come, why we have bundled? The reason of what? Bundling the data members and associated member functions. So here the reason is data hiding. So data hiding is a process of making this particular data members private so that the external world will be accessing these data members through the associated member function, not directly. This is what is called as data hiding. Understood? So, what class does? It encapsulates data members and associated member functions so that the external world cannot access these data members directly. Instead of that, they can access them through associated member functions. This is what is called as data hiding. Next comes object. What exactly object is? See, when I design a class, now for this one let me have one class. So now let me say class student, and here I will be having int role and char name of 10, let's say, and of that public section will be there. Here there are two sections. Actually, there are three. One is private, another one is protected, third one is public. Protected we will be learning about later, because for time being, protected and private both are same. Understood? So now what do we do is, we put all the data to be hidden under private section, and we write all the functions, that is associated member function, under here. Let's assume that read and print. These are the two functions which are associated with this particular data, where the external world will be communicating with these two data members through these functions. These are not simply functions, they are associated member functions, because they are written within the class with what? The data members. Now this is simply a blueprint. Nothing doing with this. It is having only logical existence. It doesn't have any existence. If you only want to create a variable, actually we should not call it as a variable. Now we want to implement this particular class. What do? Is we create an object. How do we create an object? If at all the class name is student, we say student1. Now what has happened? 1 is an object of what type? Student type, where the student is of class type. Now if at all you want to find out what is the size, if at all you would like to find out what is the size of 1, you have to count, or you have to sum up the bytes for each member. Now see here, into 2 bytes, char 10 bytes, totally 12. 12 bytes will be reserved for 1. Understood? You got my point? Now this one is called as an object. Then how can we define object? We can say that object is a runtime entity of the class. What is called as runtime? Remember, this object is created dynamically, not at compile time. Understood? That's why it is called as runtime entity. Entity is something, it is a synonym for object. So there is one subject called as DBMS, Database Management System. There you are going to learn it. Entity is nothing but it is an object. Understood? So that's why what they are saying, it is a runtime entity of the class. Created at what time? Why it is called as runtime? It got created at the runtime. That's why. That's what is called as object. So object is the implementation of the class, where the class is a plan for the object. Remember this. Next comes encapsulation. What exactly encapsulation is? Encapsulation is a process of wrapping up or binding the data and associated member functions together under the single unit called as class. What about this data abstraction? Data abstraction is a process in which we make only necessary information available to the user and we are going to hide all unnecessary informations. So why these unnecessary informations are hidden? For two reasons. First one, I am not willing to disclose it to my customers or my programmer. See here, please do remember, when we shift from procedure-oriented to object-oriented programming languages, here there will be three different users. One is class designer, second one is a programmer, third one is a user. What programmer will do? He doesn't have a time to create a classes. That's what he do. He will go to class designers, he purchase them. Class is designed by a class designers. They sell it to what? Programmers. What we programmers do, we go and purchase them. See, when we purchase a class from the class designers, they give us only necessary information. They are going to hide all unnecessary information. Why they are hidden? Because they don't like to disclose the logics. If at all you are willing to know everything, but I am not going to give complete information about the class. Why? Because I would like to hide it. Otherwise, what happens? You will design your own class. That's why. So this is what is called as abstraction. Abstraction is making only necessary information available to the user by hiding all unnecessary information. First thing, you was not given complete information because I wanted to hide something from you. Otherwise, what would happen? You will stop purchasing the classes from me. You will start what your own. You will write your own class. The second reason is a programmer is not interested. See, if at all I would like to explain it technically, then how can I tell you is, I am interested in CLR/SCR. But I am not interested in finding out how CLR/SCR works. So that's why that information has been hidden. If at all you are willing, then also that information will not be given to you. Understood? I will be using SQRT function. I am using it, but I know that the SQRT function is going to give me the square root. But I am not interested in knowing, or that information was provided to me, like how exactly the square root has been found in that particular function, what code has been written. This is what is called as data abstraction. Data abstraction is a process in which we will be knowing only the necessary information, or unnecessary information will be avoided. So when you purchase a particular class, we won't give you complete information. You'll be given only necessary information. Understood? And next comes inheritance. What do you mean by inheritance? Inheritance is a process in which, the properties and behavior of one class are copied to what? Another class. Understood? Why it is so? In what cases we'll be using it? See, it is used in two cases. Now let's assume that already one class is existing. Here there is roll number and name. Now I have designed one class for a student. What is it? What members it has? It has roll number and name. Suddenly somebody came to me and told to redesign this particular class. He told, I want to add last name, father name, total, average into this particular class called a student. If at all I do the modification in the same class, then what happens, an existing system may be hampered. That's why what do? I will create one more class I will inherit all the traits and behavior of this class to this class. For example, let's assume that class advanced student, I will name it as advanced student. Now all the things are inherited over here. Additional things what I wanted to add? I want to add father name, last name and total average. What do? I will say char last name of 10, int total, float average. Now what has happened? As this particular class is inherited to this class, now this class virtually having roll number and name, actually having last name, total and average. So now a person who had asked me for the changes, enhancement of the program will be given what this particular class. Now see, if at all something happens, it is going to affect only the new class, not the old class. Old system is running fine. I am modifying my program, enhancing my program without affecting the existing system. In this particular situation, we will be making use of inheritance. And one more reason, now let's assume that there are two classes. They are having some common properties. Instead of writing them twice in two different classes, only once you write and inherit that class to these two classes. Reusability. So this is the second reason because of what we'll be making use of inheritance. Understood? And next comes polymorphism. So what do you mean by polymorphism? Polymorphism means that multiple forms in different situations. For example, now let's take plus operator. Now this plus operator has been designed in such a way that it can work with built-in or inbuilt data types. Basic data types we can call them as. Plus operator work with integer, plus operator work with float, plus operator work with some other data type also. But please do remember, already it is overloaded. Because this is capable of adding two integers. This is capable of adding two floating type of values. This is capable of adding one int, one float. Capable of adding one float and one int. Now already it has been overloaded. So it has been done by what the compiler designer. But now what this C++ do is, it has given us a chance or opportunity to over this plus operator, even to make it work with user-defined data type. For example, now if at all I consider A, B, C as arrays, simply I can't say C equal to A plus B to add the contents of A with B and put them under C. It never works. Here see, this also doesn't work. Assignment operator also doesn't work and plus operator also doesn't work. Why? Because they are designed to work only with the basic data types. Where arrays are not basic data types, they are user defined. Now what I can do is I can overload this plus operator in such a way that simply by putting plus in between two arrays, these two are added and the result will be put under C. This is what is called as polymorphism. Now see, plus operator is overloaded. This is what is called as operator overloading. And one more facility is given. See, now what happens, I want to write 4 functions. What those 4 functions are? One function to add 2 integer types. Another function to add 2 float types. Third function to add 1 int and 1 float. And fourth function is to add 1 float and 1 int. So in such case, in C language, what we do? We name them as add 1, add 2, add 3, add 4. 4 names has to be given for the function. We gave 4 different names. Now for the programmer, it becomes a bit difficult, like what function is going to add what. So again, I need to go and see the definition and to decide like what function, whether add 2 function is going to add 2 integer type of values or add 4 function is going to add 2 float type of values. I need to frequently go back and see, otherwise I have to refer to the manual. Instead of that, C++ gave one more opportunity in which we can give same name for multiple functions. Understood? Now see, previously we used to give like add 1 for int and int, add 2 for float and float, and add 3 for int and float, add 4 for float and int. So I gave 4 different names. Here user will be confused like what function does what. It is bit difficult for user to understand what function does addition of what. Instead of that, C++ gave us opportunity of giving same name for multiple functions. See, all functions are given name as add. Now it is a headache of compiler to decide which function has to be called. Now see, if I say add 5,6, automatically the compiler will call this. Now it is none of my business. This is what is called as function overloading. Why it is called as function overloading? Why? Because there are multiple functions with the same name but with a different argument list. Please do this, remember this. Understood? You can give same name, but you can't have same argument list. For example, it is not possible for me to declare one more function over here, which is going to take 2 integer type of values. No, it is not possible. You can give same name, but argument list must be different. See, one more thing you must remember. Whenever I am writing a function, we will be having return type. Am I right? And here you will be having function name. And here you will be having argument list. Understood? So this is what is called as, whole thing is called as function header. What it is called as? Function header. Only if I consider this function name and argument list, okay, this is what is called as signature. What it is called as? Please try to understand the difference in between the function header and then the signature. What exactly the difference in between function header and signature? Function header includes return type, function name and argument list. You got my point? But the signature is only the function name and argument list. So that's why when you are overloading the function, the signature must be different. We will be learning more about that in coming session. Understood? So now let's come back. So I said add 5,6. I'm least bothered. I'm not worried like what function is going to do what. Simply I say add 5,6. As both are of integer type, this function will be called. If I say add 5.0 plus 5.0, then automatically the compiler will decide, okay, I need to call this particular function. Like that, the decision is made by the compiler on the basis of the argument what we have passed. As same name is given for the multiple functions with a different argument list, this is what is called as function overloading. Understood? So function overloading is going to help us in this particular manner. This is what is called as polymorphism. Polymorphism is nothing but giving multiple forms for a single thing of what particular programming language. Understood? That may be operator or that may be a function. The next thing is dynamic binding. So one thing you must remember. So already in the last session we have discussed about, that is, something is going to happen at the compile time and something is going to happen at runtime. What do you mean by compile time? Compile time is a time, it is before you start the execution of the program, not you, before the operating system starts the execution of the program, no, the time is there, no, that's what is called as compile time. So if at all, I ask you how much time it takes to prepare the uppit or upma, usually what people will do is, they will start counting from start the cooking. But actually, prior I starting cooking, I will be doing so many things, right? I'll be chopping vegetables, I'll be cleaning something, and so on, right? So that time also has to be considered. See, before I start cooking, what all things I perform now, that's what is called as compile time. And after preparation is done, when a real cooking starts now, that's what is called as runtime. Understood? So remember, whenever we do what the function, see, there are so many things which are going to happen at compile time of the program. What all things will happen? First, it is going to declare all the variables. Second, it is going to declare all the arrays. So arrays are declared at compile time. That's why it is not possible for us to decide the size of an array at the runtime. Remember this. Even the arrays are created at compile time. And third one, we'll be using function calls. Right? We'll be calling so many functions, let it be inbuilt function or user-defined functions. So in such cases, at the time of compilation only, it will be decided like what function body has to be called for what particular function call. It will be decided at what time? Not at runtime. It will be decided at compile time. Remember this. But sometimes what happens, a compiler is going to decide which function has to be executed for a particular function call at runtime. If at all the decision is made, like what function has to be executed for a particular function call at runtime, it is called as dynamic binding. See, normally it will be a static binding. What do you mean by static binding? If at all the compiler decides, the operating system is going to decide like this particular function should be executed for this particular function call, that's what is called as static binding or early binding. Or if at all the operating system is going to decide this particular function should be executed at runtime, then it is called as late binding or dynamic binding. See, there is one concept called as function overriding. Understood? Function overriding, where the function name as well as the argument list will be same. See, I told you in function overloading what happens? What function has to be called will be decided on the basis of what? The argument list, not on the basis of the name. Why? Because multiple functions are there with the same name. Decision was made with respect to the argument list, but that was decided at the compile time. But now what has happened in function overriding, there are two functions with the same name and same argument list. In these cases, the operating system or the compiler is going to decide what function must be executed at runtime. As it is decided at runtime, it is called as dynamic binding or late binding. Got my point? So next one is message passing. So what do you mean by message passing? See, when a different number of objects of a same class are created, they want to interchange some kind of information. In such case, what? Variables or the objects will be interchanging what? The messages. And it has been connected like, see here, now I have created one class and here we have two variables a, b. So this is under private section. Under public section, we have two functions, that is read and print. See, this is how the class looks like. Now let's assume that the body has been written for read and print. Now the name of class is A, let's assume, capital letter A. Then what we do is, still it doesn't have what? The physical existence. It is having only logical existence. I told you, when we define a class, it will be having only logical existence. If you want to give the physical existence, you have to create the object. How do you create the object? I will say A1. Now what happened? Now 1 is the object of class A type. So now what has happened? 1 got created, but it is having some kind of garbage values. See, always what should happen is when the object got created, it should have some initial value. But with respect to C++, what happens, this particular object doesn't have anything. It is having some garbage. For example, 1 has A and B. A is having 1.A is having garbage value. 1.B is also having some garbage value. I want to read some valid value from the user to AB of object called as 1. Then what do I do is, I will say 1 dot. Now let's assume that read int int m, int n. Understood? So this is the header of what this particular read function. Now what do I do is, I will say 1 read 5, 6. Now what happens, if at all the program has been, this particular function is being written properly, once A will be assigned with 5, once B will be assigned with 6. Understood? Now this is the message which is passed by this particular object. To whom the message has been passed? The message has been passed to the function called as read with two values, that is 5 and 6. So this is what is called as message passing by what? A particular object. So for your convenience, how can we remember when particular object is going to call a particular function? It is sending out one message to this particular function, message passing with these particular values. This is what is called as message passing.